All right, ladies and gentlemen, welcome to today's trigonometry class. And today we're actually going to talk about um, Pythagorean identities. So in our previous video, we talked about reciprocal identities, and we also talked about quotient identities. One other identity that we're missing is the Pythagorean identity. So what I did in this video to summarize the content is I wrote the three Pythagorean theorem or Pythagorean identities, excuse me, that are given to you guys in your textbooks. And we're going to see three quick examples of how to use them. So the first Pythagorean identity that we have is that the sine squared of theta plus the cosine squared of theta equals 1. Likewise, the other Pythagorean identity that we have is that the tangent squared of theta plus 1 equals the secant squared of theta. And last but not least is that 1 plus the cotangent squared of theta equals the cosecant squared of theta. So with that in mind, guys, what we're going to do is we're just going to apply some of them. Now, remember that they're adding, so the commutative property also applies. So if I have the sine of squared of theta plus the cosine squared of theta equals 1, I can also say that the cosine squared of theta plus the sine squared of theta equals 1, okay? So they are reciprocal identities. And let's look at they do follow the reciprocal properties. So that being said, guys, let's look at this. It says find the cosine of theta. I forgot to write theta. And the tangent of theta if the sine of theta equals 4/5 and the terminal side lies in quadrant 2. Again, I'm going to read that example. It says, find the cosine of theta and the tangent of theta if the sine of theta equals 4/5 and the terminal side lies in quadrant 2. So we have to take into account the same thing that we did in our previous class. All students take calculus, where all means that all in the quadrant 1, all trigonometric functions are positive. Students, which means that in quadrant 2, only the sine is positive. Take, which means that in quadrant 3, only the tangent is positive. And calculus, which means that only the cosine in the quadrant 4 is positive. So that being said, we need to apply that rule here as well. So they want us to find, let's look at the problem. They want us to find the cosine of theta. So let me go ahead and write theta here. So they want us to find the cosine of theta, which is this, and the tangent of theta, which is this, and we're being given the sine of theta, which is down here. So if I look at my trigonometric functions, I need, or trigonometric Pythagorean identities, excuse me, I need to look for one that includes sine, cosine, okay? So I need to find one that includes sine or cosine. Why sine or cosine? For two reasons. One, because I'm being given the value of the sine, and one of the things I'm being asked to find is the cosine. Again, what do I have given? I have the value of the sine, which is 4/5. So I have the sine of theta, which is 4/5. I need to find the cosine, because that's what I'm being asked to find, the cosine of theta. And I'm being asked to find the tangent of theta. So out of all three trigonometric identities that I have written there, the one that fills in most of the gaps is the first trigonometric identity, which says that the cosine plus squared plus the sine squared of theta plus the cosine squared of theta equals 1. And it's the one that comes close to it again, because what I'm being given in the problem is the sine, and I'm asked to find the cosine and the tangent, and the only one that satisfies most of these needs is the first trigonometric identity, because the second trigonometric identity has tangent, squared, and secant. So let's go ahead and plug in. So what I might do in this step is just plug in the values. So the sine squared of theta is actually going to be 4/5 squared. So I have 4/5 squared plus the cosine, which is what I need to find, plus the cosine, which is what I need to find, equals 1. So what I do now is first I'm going to solve for cosine, and it's not just cosine, it's the cosine squared of theta. So I have to solve for the cosine. Well, actually, no. The first thing I need to do is I need to square this. And 4/5 squared is 16/25, because 4 times 4 is 16, and 5 times 5 is 25. So I have 16/25. 16/25 plus the cosine squared, which is what I'm looking for. Cosine squared. Cosine squared of theta equals 1. So all I'm going to do now is I'm going to continue over here. I'm going to solve for cosine. And what that means is I'm going to subtract by 16/25. So I'm going to subtract by 16/25. And this is going to cancel out, right? And then I have 1 minus 16/25. So my equation is now going to be rearranged where I have the cosine squared of theta. The cosine squared of theta equals 16/25 minus 1, right? So 16/25 minus 1, and here we have to use or solve, right? Use fraction subtraction in this case to solve this. Now there are various ways to solving this fraction. First thing is to go ahead and write 1/1, so I have the same denominators. Now one method that I like to use is I like to use the butterfly method, in which I multiply my denominators and I say the 25 times 1 is 25, or 25 is the common denominator if you guys want to do it that way. Let's see if I can move this bar over here so I can have a little bit of space. So I lost my marker. Here we go. I'm sorry, guys. So 25, because again I use my butterfly method, which is multiplying the 25 times 1, and then I kind of cross multiply, and I multiply the 16 times 1, so that would be the numerator here, 16 times 1, and then of course or actually I'm sorry, actually yeah, you can do it that way. You can then 25 times 1 is 25. So give me 1 second, guys. I'm just making sure that everything here is correct. So one second, guys. Okay, so I just realized that I made a mistake here and I rearranged the equation wrong. So let me fix this mistake. I knew something there wasn't working, so I just realized that I rearranged arranged the equation wrong, and that was going to give me a negative answer. And that was so. Let me go ahead and erase this, guys. Pardon the mistake. Let me go ahead and fix it. So it's not 16 over 25 minus 1. It's actually 1 minus 16 over 25. So let me go ahead and fix it. So if I go back to what I was doing prior, I realize I subtracted 16 over 25 and this cancels out, and I know that the cosine squared of theta is 1 minus 16 over 25, which is what I should have written here. And I realized that I made a mistake. So this is actually 1 minus 16 over 25. And now, guys, we can go ahead and solve the fraction like I was doing. We shouldn't have any problems with this now. So I apologize for that. And we will carry on. So 1 over 1. And then again, I use my butterfly method, which is 1 times 25. And that's going to be 25 down here. Actually, let me see if I can write it a little bit further down so I can have some space at the end of the problem. Give me 1 sec. Okay. So again, this is going to be 25, which is going to be my denominator. 25, and then minus 25. So now what I do is I go ahead and cross multiply, and I can cross multiply the 1 times the 25, right? And that's going to equal to 25. And then I'm going to multiply the 1 times the 16, which equals 16. Then I subtract, and that would be that the cosine squared of theta equals 9 over 25. Now, here is what I'm going to do now. It says the cosine squared of theta, and in order for me to find my tangent, I have to simply say the cosine squared of theta is 9 over 25, so I have to calculate the square root. So that will give me the cosine. So 9 over 25. And I'm actually going to go ahead and find the square root of the cosine squared. And I'm going to go ahead and find the square root of 9 over 25. And that's going to be that the cosine, and I know I'm kind of invading some space here, but that's all right. The cosine of theta is going to be plus or minus 3 over 5. Because remember that whenever you're working with the square root, you always write your answer in plus or minus 3/5. So I found the cosine of theta, and the cosine of theta is 3 plus or minus 3/5. Now, to find the tangent of theta, we have to go ahead and use the quantity identities that we did yesterday. So let me go ahead, and we found our cosine of theta. Now, in our previous class, in the previous video, we talked about the quotient identities, and we said that the quotient identities, the tangent is actually the sine over the cosine. So sine divided by the cosine. The sine divided by the cosine. The sine divided by the cosine. So what we need to do is just find the sine which was given to us, which is 4/5 divided by 3/5, which is what we got. Now, one thing before I go on, 3/5. Now, one thing I forgot to do here is that in this case, the cosine is going to be -3/5. And the reason why the cosine is -3/5 is because they're saying that the terminal side is in quadrant 2. And in quadrant 2, the only positive trigonometric function that I have is the sine. So the cosine of theta is actually -3/5. So when I look for my tangent, and I know that my tangent is my sine over my cosine, I'm dividing 4/5, which is the value that I got from my tangent, by -3/5, which is the value that I got for the cosine of theta. So let me go ahead and erase this so I can have some space. We know that the cosine of theta equals -3/5, and I'm going to go ahead and write it here, and that way I can erase and have some space to finish the problem. And if you guys have any doubts or questions, you can go back to the video, rewind the video, and go back to the problem. So I know that the cosine of theta is -3/5, and I'm looking to find the tangent of theta, and I know that the tangent of theta is sine divided by cosine. So we have the sine, which is 4/5, and we just calculated the cosine, which was -3/5. So now I'm going to erase this, and we can have some more space. So to find the tangent, you simply divide the sine. So I'm going to say that the tangent equals the sine over the cosine. So the sine in this case would be 4/5 over, or divided by, -3/5. And remember that whenever we're dividing a fraction, sometimes you'll see them like I'm doing it. Sometimes you'll see them like written or one over the other. It's the same thing. So whenever you're dividing a fraction, remember that you're multiplying by the reciprocal. So this means that this is going to be 4/5 times the opposite of -3/5, which would be -5/3. And you're going to multiply it by the reciprocal, which is -5/3. And because I'm multiplying fractions, I can use cross cancellation, which means that this is going to cancel out as well as this. It is going to be a 1, and this is also going to be a 1. So basically, 4 times 1 is 4, or -4, because remember that this is -5/3. So this would be -4/3. So the tangent of theta is -4/3. So you saw how we used a Pythagorean identity, and we also used a quotient identity. So the tangent of theta is -4/3, and that's how we use the trigonometric function in that case to find the tangent. Now let's go ahead and look at the other example. So I'm actually going to go ahead and start erasing here, clearing up my board. Again, just to kind of review what I did. Remember that my tangent was -3/5. I need to find the tangent of theta, which is sine over the cosine. So the tangent of theta would be the sine, which is 4/5, divided by the cosine that we had calculated, which is negative 3/5. Whenever we're dividing fractions, we multiply by the reciprocal. So I turn this into negative 5/3. I cross cancel the 5's, and then which would be 1. So 4 times negative 1 is 4, and 1 times 3 is 3, meaning that the tangent of theta is negative 4/3. So now I'm going to go ahead and clear up some of the spaces, some of the space here. To work on example number 4, which is very similar to example number 3. When we're working with the Pythagorean identities, we need to understand that sometimes we're going to have to also use the quotient identities. So one thing kind of this isn't like everything is separated, but rather everything is kind of meshed together, and this is all small pieces of a larger puzzle. So let me finish erasing this so that way we can do example number 4, and I can actually have more space to work with the exercises and not make everything look so scrunched together. If you have any questions, you can always pause and rewind the video, and you can verify what was done. So let's look at the other exercise. Let me get my spotlight so I can read the problem. The problem says, if the sine of theta, or find the sine of theta and the cosine of theta, if the tangent of theta is 3/4, and the terminal side of the quadrant lies, or the terminal side of the angle lies in quadrant 3. So again, find the sine and cosine of theta if the tangent of theta equals 3/4 and the terminal side lies in quadrant 3. So what do we have? Well, what do we need? We need to find the sine, which we don't have. We need to find the cosine, which we don't have. And the only value that we do have is the tangent. So the sine of theta, the cosine of theta. These are our mystery values, what we don't have. And the tangent, which is 3/4. So the tangent of theta is 3/4. So notice we only have a tangent value. So we need to look at our trigonometric, our Pythagorean identities and see which one of these identities best fits what we have. The only one that we have that can remotely fit is the second trigonometric identity. It says the tangent squared of theta plus 1 equals the secant squared of theta. Now, I know that doesn't make any sense, but remember that the secant is the opposite of the cosine. So we can actually use the reciprocal identity to solve our problem. So again, we're seeing everything kind of mixed together. So let's go ahead and plug in the numbers. Now we have the tangent squared. So this would be 3/4 squared. The 3/4 squared, which is this, plus 1 equals the secant squared of theta. Secant squared of theta. Now we can just turn that into the cosecant squared of theta, or 1 over the cosine squared of theta, and go ahead and just work with that. Or we could just apply the identity function. So we have 3/4 squared plus the plus 1 equals the secant squared. So let's go ahead and 3/4 squared is the same thing as saying 9/16, because 3 times 3 is 9, 4 times 4 is 16, so 9/16 plus 1 equals the secant squared of theta. So the secant squared of theta. All right, now we're going to work with our fraction first, and then we're going to be able to work with what's necessary. So again, we can, and I'm actually going to go ahead and add that here. So let me draw that arrow indicating that I'm continuing the problem on this side. So we're going to use the butterfly method as well. And we write this over 1, and we can just say, well, I'm going to multiply 16 times 1. So you're going to say 16 times 1 is 16. And then you're going to multiply, well, 9 times 1, because this is the other method, cross multiplication. And it's going to be 9. And then we're going to add, we're going to do the same thing on this side, and we're going to cross multiply 1 and 16, which is 16. That's why it's called the butterfly method, because it kind of resembles a butterfly. So 16/16, and we're going to add, and 9 plus 16 is 25. So we actually have, and move this here, we actually have 25 over 16, which is what you get when you add 9 plus 16. And then the square equals secant squared of theta. So what we want to do now is, in order to find the trigonometric functions that we're being asked to find, which are the sine and the cosine, what we need to do is we need to find the square root of this function to get the secant. So the square root of the secant squared is the secant of theta. So that would be secant of theta, and the square root of 25/16 is 5/4. Now we have the secant of theta, and that equals 5/4, or plus or minus 5/4. So we have 5/4, which is the secant of theta. We are still missing the cosine and the sine. So before we do that, we want to we're going to convert. See if I can move this over here. We're going to convert this, and again, I'm going to draw another arrow. I know that this is kind of crazy. We're going to convert this, and we're going to say that the secant of theta is the same thing as saying 1 over the cosine of theta. Anyway, sorry for that. So what we want to do is we want to first of all, before I find the cosine of theta, I want to let you guys know, or I want to go back real quick to the problem. And in the problem, it says that the terminal side lies in quadrant 3. Now, the only positive function The only positive function that I have in quadrant 3 is the tangent, which is already being given to me, which means that this secant is not positive. So my answer here is not positive 5 over 4, but it is negative 5 over 4. And now I know that the secant is the same thing as saying 1 over the cosine of theta. So 1 over the cosine of theta equals negative 5 over 4. So 1 over the cosine of theta equals 5 over 4. So what you do is you simply say that this is going to be 1 over the cosine of theta, which is negative. So the secant is 1 over the cosine. So we just change that to negative 5 over 4. And what we do with that is we divide it, and this would be the same thing as saying 1 times the reciprocal, which is negative 4 over 5. You know what? No, I think I found a better way of solving this, a less confusing way for you guys. So if I want to find the cosine of theta, what I can do instead of doing that is just kind of solve it like an equation. And this is what I mean by solve it like an equation. I can, if I want to solve for the cosine of theta, all I do is I multiply by the cosine of theta on both sides. So I'm going to multiply by the cosine of theta here. And this is going to cancel out. And I'm going to multiply by the cosine of theta here. So that's going to give me an equation. This 1 equals negative 5 4 times the cosine of theta. So what I'm going to do now is divide this equation. So I'm going to say the cosine of negative 5 over 4 equals 1. And that means I have to divide. So I'm going to multiply by the reciprocal, which is 5 over 4, negative 4 over 5, excuse me. So this is going to be negative 4 over 5. And I'm also going to multiply by negative 4 over 5 here. And this cancels out. And that would be the cosine of theta equals negative 4/5. So now that I have the cosine of theta, which is negative 4/5, I can find the other missing value, which is the sine. So I'm going to go ahead and erase all this. Again, if you have any questions, you can feel free to review the process. Okay, again, what I did in the last thing, it says that the 1 over the cosine of theta equals negative 5 over 4. So I isolated the variable of the cosine of theta, and that would be the cosine of theta equals negative 5 over 4. Or excuse me, the cosine 1 equals the cosine of theta, which is negative 5 over 4. I divide by the reciprocal, which would be negative 4 over 5, and that means that the cosine of theta is negative 4/5. Again, if you guys have any doubts or questions, you know where to find me, and you know, or you can rewind the video, okay? So let's go ahead and okay, so we know that the cosine of theta, pardon me for that, the cosine of theta is negative 4/5. Now we need to find the sine. So in order for us to find the sine, we need to use the trigonometric identity, the Pythagorean identity. And the only Pythagorean identity that has sine and cosine is the first trigonometric identity. So what I'm going to do is just use the first trigonometric identity. It says the sine squared plus cosine squared equals 1. So, and that's the one I need to find the sine. So I'm going to say the sine squared of theta is what I'm looking for. The sine squared of theta is what I'm looking for. Okay, the sine squared of theta, which is what I'm looking for, plus the sine squared of theta, which is what I'm looking for, plus the cosine square. But the cosine square we already know is negative 4/5 squared. So I'm just going to go straight into plugging in the numbers. 4/5 squared 4/5 squared is 4/5 squared is 4/5 squared equals 1. So we're going to say that the sine squared of theta remains the same, and instead of saying negative 4/5, it would be negative 16 over 25. So the sine squared of theta plus 16 over 25 16 over 25 equals 1. So we're going to subtract again. We're going to say that the sine, we're going to subtract 16 over 25. We're going to subtract 16 over 25. And that will be 1. I'm going to write it sideways. 1 minus 16 over 25. So that way I have more space. So 1 minus 16 over 25. And this is going to cancel out here. And we're going to use the butterfly method like we did. And we know that this is going to be 25 at the bottom because you multiply 1 by 25. And we're going to multiply 1 times 25, which is here. So we already multiplied 1 times 25. Now we're going to multiply 1 times 25 again, which is going to equal to 25. And we're going to multiply 1 times 16, which is 16, which is going to be that the sine squared of theta, equals 9 over 25. And we need to find the square root of it. And we're going to find the square root of it. Let's see if I can actually have more space. And we're going to have we're going to say the square root of 9 over 25. See if I can extend that square root a little bit. Nine over 25, and that's going to equal to, and of course the sign of squared, and I'm going to write it on this side. That would be the sine of theta equals plus or minus 3 over 5, but it's saying that it is in quadrant 3, and in quadrant 3, the terminal says in quadrant 3, so in quadrant 3, the sign is negative, so my answer is actually the negative, the sign of theta is the negative 3 over 5. Okay, so the square root of theta is actually negative 3 over 5. Sine of theta is negative 3 over 5. And that's how we do example 2. I know it's a little tedious, but basically we found our sine, which is negative 3 over 5, and we found our cosine, which was 4/5. So that being said, now let's look at the last example of this section, which is example number 5. And let's look at example number 5. Example number 5 isn't really giving us any detail. More than anything, it's asking us to simplify. So sometimes when we have Pythagorean identities, we can simplify them. Sometimes you'll be asked to find the trigonometric functions. Other times you'll be asked to simplify them. So let's go ahead and look at that last example. And this will be the last example of this video lesson. It says multiply 1 over the cosine, or 1 minus the cosine of theta times 1 plus the cosine of theta. And at the end, even though I didn't write it, they want us to simplify. Okay, so I'm going to read the problem to you guys again. Example number 5 is asking us to it says multiply 1 minus the cosine of theta times 1 plus the cosine of theta and multiply. So what we're going to do, and I'm going to write it up here, is we're going to multiply 1 minus the cosine of theta. 1 minus the cosine of theta. I'm sorry. Let me rewrite that. I realized I was writing it wrong. So we're going to multiply 1 minus the cosine of theta. And to do this, we're going to use FOIL, just like we would multiply polynomial expressions. So 1 minus the cosine of theta times 1 plus the cosine of theta. So 1 plus the cosine of theta. Let's go ahead and multiply it right here. 1 plus the cosine of theta. 1 plus the cosine of theta. 1 plus the cosine of theta. And we're going to say, well, 1, we're going to use the FOIL, which means we're going to multiply 1 times 1, and then 1 times the cosine of theta, and likewise, okay? So if we multiply 1 right here times 1 is obviously 1. Then we're going to multiply, so we multiply 1 times 1. Now we're going to multiply 1 times cosine of theta, and it's going to be plus the cosine of theta because it's positive. So plus the cosine of theta. 1 plus the cosine of theta. And we're going to do the same thing here. So the cosine, the negative cosine of theta plus times 1 is minus the cosine of theta. So minus the cosine of theta. And we're going to multiply the negative cosine of theta times the positive cosine of theta. Okay, so we have 1 plus the cosine of theta minus the cosine of theta minus the cosine of theta squared. So minus the cosine of theta squared. Cosine of theta squared. One minus the cosine of theta squared. Theta squared. Now we are going to work with the functions. Okay, so we have 1 minus the 1 minus the cosine. So we have the plus cosine of theta. So these two cancel out because it's plus the cosine of theta minus the cosine of theta. And that's going to cancel out. And that's going to leave me with 1 minus the cosine squared of theta. And that's what we have left over from that fraction. So from that expression, so we have 1 minus the cosine, the cosine, or 1 minus the cosine of so 1 plus the cosine of theta, 1 minus the cosine of theta times 1 plus the cosine of theta equals 1 minus the cosine squared of theta. So to find or to simplify this expression, what we need to do is rewrite our Pythagorean identity. So I know that the Pythagorean identity says that sine squared plus cosine squared equals 1, but I'm going to rewrite that now as the sine squared minus theta equals 1 minus the cosine of theta. So basically, let me write it in a different color to explain what I'm trying to get at. Is what I'm going to do is I'm going to look at my Pythagorean identity, which says that the sine squared of theta plus the cosine squared of theta equals 1. So in order to simplify the expression that I have here, which is 1 minus the cosine of theta, I have to rewrite the expression. Okay, so what that basically means is that if I were to take this and solve for sine, I would have to subtract by the cosine of theta equal squared, excuse me, and I would subtract by 1 minus the cosine of theta squared. So again, once I did that multiplication and I got that my answer was 1 minus the cosine of theta squared, what I have to do now in order to simplify it is solve the Pythagorean identity that says sine squared plus theta squared, or excuse me, the one that says sine squared of theta plus the cosine of squared of theta equals 1. I have to rearrange it in order to simplify it. And the way I do that is by solving by the sine, which is what I'm doing here. So this cancels out and it's going to be if I solve it for sine, the answer would be that the sine of squared of theta, the sine squared of theta equals 1 minus the cosine of theta squared. 1 minus the cosine squared of theta. Now, what that means ultimately, guys, is that 1 plus, or 1 minus the cosine of theta times 1 plus the cosine of theta equals the sine squared of theta. So our answer is, or our final answer is 1 minus the cosine of theta times 1 plus the cosine of theta equals sine squared of theta. All right, guys, hopefully this video will help you guys out. If you have any doubts or questions on the Pythagorean identities, you know where to find me. So stay safe and we'll see each other very, very soon. So until our next class, bye.